Write the equation of the line that has a slope of -2 and a y-intercept of 5. How do I do that? Somebody tell me. Somebody tell me. How do I do that? How do I write this equation? What do I do first? Raise your hand. Cooper, thank you. Okay, so it's got to be in this form. This is the form of a line, right? Where, let's just do this. What is M? Rate of change or slope. What's the B? Start value, or what's another name for it? Start value or y-intercept. Okay. What's the x? That is an x-coordinate now. Is there only one? There's only one x-coordinate I'm hearing. Is that true? Think about that. Is there only one x-coordinate for every line? It's infinite, right? How about the y-coordinates? How many y-coordinates can you have for a line? It can go on forever, right? Because that line goes on and on and on forever. For every x-coordinate, there's a y-coordinate. For every y-coordinate, there's one x-coordinate because it's linear, right? It's a straight line. So that's why you write arrows on the end of your line. So what's the y-intercept here in this up here? 5. So where does it go? It goes right here. There's my y-intercept, or my start value. How about the slope? What's the slope? Where does it go? Right here. It's a -2. What do I attach to it? Everybody get that? Y equals -2x plus 5, right? Okay. Pretty easy. That's kind of an extension from yesterday. Do this one. Write the equation of a line. This is a little different. It has a slope of 4/3. So is this going to be a positive or negative sloping line? Positive, because 4/3 is positive. And it goes through the point -3, 1. You cannot graph it. You may not graph it. That's the catch. I want the equation of that line right there. See if you can take a few minutes, figure out how to do it. Go. Talk to people around you. What are you thinking? Right? Start with this form right here. The slope is 4/3. What's the line? Like this. What do we know? Let's just put in what we know. This is 4/3, right? Everybody write that equation down underneath your original equation, or under your y equals mx plus b. What other information do I have? I have a coordinate point. I have an x value and a y value. Where would that go here? Well, the y value is going to go here because it's 1. Right? I'm going to plug it in. The x value is going to go here, which is -3. I don't have the b value, so I can solve for the b value and find it and then put it back in. Right? So, I'm going to. Yeah, I'm going to. Watch. So this, you have to be pretty good with fractions, right? What is 4/3 times a -3? Well, it's -3 over 1. It's -12/3. So I'm going to let's do a little revision. -12/3. Everybody understand where I got -12/3? Because 4 times -3 is 12, and then the denominator is just 3 times 1, which is 3, okay? Plus b. We don't know what b is. That's what we're solving for. Well, what's -12/3 as a whole number? Now what do I do? Plus 4 on both sides. I get 5 equals b. That's just part of it. So my equation, that's my b value. So you take this b value that you solved for, and you plug it in there. So my equation is, we'll do it in green, y equals 4/3 x plus 5. So you start at 5. You start at 5, that's your start value, then you go up 4 over 3, up 4 over, then that's your line. Okay? So, just to review, you take your equation, take 2 points that you know, plug them in there, solve for b, and then you have the rest of your equation. Does that make sense? Yeah? Okay. Here's what I want you to do. Get a piece of graph paper out and draw a coordinate plane for me. Okay? Let's get a piece of graph. So, are you using a straight edge? Very nice. Those are very straight lines. Okay. So I'm going to go back here for a minute. I can get out of here for a second, right? So watch. It says find the equation of the line that contains AB. So here's what we're going to do. So AB is this line segment right here from there to there, right? AB. So we've got a point negative 2, 5 and 4, 8. Now, write this down. You always do this. Write your equation. Y equals mx plus b. It helps you figure out where things go. How many points on the line AB do I have? I have 2. 2 points. I have 4, 8, and I have negative 2, 5. So I have an x coordinate and a y coordinate, but I have 2 of them. Doesn't matter which one you use to figure out the equation of that line AB. I'm seeing Cooper shake her head no. What? Okay, not necessarily. When you're finding slope, you do, right? But does it matter which 2 points I use to put into the equation to find out what B is? Why? Why? Are both of those points on line AB? Yeah. So it doesn't matter. But first we have to find our slope of that line of AB. I'm going to do a slope triangle without doing a bunch of math. You could do y2 minus y1 over x2 minus x1 and find the slope. But in this case, we don't need to, because I look at this line and I think, okay, can I go up with a right triangle and hit my line again fairly quickly and easily? Yeah, it's not a weird line. It goes through 2 points. So if I start at negative 2, 5, right, and I go like this, how many did I go up? 1, so that's my rise. And then how many do I go over? That's my run. There's my slope. I go up 1 over 2. So my slope's 1/2, right? So I've got part of that. I'm just going to put x here for now, and I'm going to put y here equals b, or plus b, excuse me. Now, can I figure out the rest of it based on those 2 points on that line? Yeah. Which ones would you like to use? Do I use the negative 2, 5? Do I use the 4, 8? Raise your hand. Raise your hand. C is not on this line, AB. That's why. We're finding the equation for AB. So where we're going with this, we're going to find the equation for all 3 of those lines, because there's 3 of them, right? So I heard somebody, raise your hand if you want to use 4, 8. 1, 2, 3. Okay, raise your hand if you want to use negative 2, 5. Okay, so use whichever one you want. I'll do both of them. So the people who raised their hand for 4, 8 use 4, 8. The people who use negative 2, 5 use negative 2, 5. Go. Plug them in and see what you get for a B value. I'll do the 4, 8 first because that's what I asked. Oh, it's 4, not 5. that what you guys got? Okay. Why does it work out the same for both? Both those points are on that line. Doesn't matter what you use, I guess is my point. Now, look at that line visually. Where does it cross the y-axis? It crosses at 6, right? So am I correct? Probably. Okay. Here's your task. I want you to find the line of BC, or excuse me, the equation of the line for BC and the equation of the line for AC. Go. On your own. In y equals mx plus b form. Okay? So that's what you guys are savvy. Is there more than one, I mean, how many x values are there for, let's say, AB? I haven't heard the right answer yet. How many x values are there for the line AB? Is it infinite like before? It's a line, is it a line or what is it? It's a line segment, right? So look at this. This is called, you've heard the term maybe domain and range a little bit? I'm going to introduce it to you. There's this thing called domain, and it's all of the x values for a certain line. So if I were right here at -2, would I be on my line AB? Sure would. My x value. So if I'm at -1, would I be on my line? If I'm at 0, would I be on my line? Okay, so from here, from this distance, I'll actually write it up here. From this distance right here to this distance right here, there's x values for each one of those, right? There'd be 6 x values. So the domain, right? So the domain would be -2 to a +4. That's the domain. That's all of the x values on that line. How about the y values on that line? Well, y goes this way, right? This is the y-axis. This is the x-axis. Okay. It's from right here. Oh, I went too far. Let me redo that. It's from here to there. How many are there? 1, 2, 3, 4. So the range of that thing is from 2, 4, 5, right? A +5 to a positive what? 8. So that's so in this line right here, those are the domain and range of that line, okay? All the x values and all the y values. It's not a line, sorry, line segment. It's not a line because it doesn't go on forever and ever. Yes? Absolutely. You could start here, and I go up 1, 2, 3, 1, 2, 3, and over 1, or sorry, I went 1, 2, 3, over 1, 2, 3, 4, 5, 6, 7, or 6 in between. Yeah. So there's 6 values for each. Okay. All right. Let's go back here for a minute. So we found A, B, and C are step 1, 2, and 3. Ryan made his own triangle. Oh, you get to make a triangle. He chose 3 points and wants you to find the equations of the 3 lines that make up his triangle. His points are, write these down and graph this with a straight edge, because Cooper's getting really good at writing or drawing lines with straight edges. +3, 3, -2, -7, -7, 2, -2, excuse me. Can you find the 3 linear equations that intersect to make his triangle? Okay. Can you use what? You can use this -7, -2, or you can use -2, -7. But you have to put them in the right spot. One's y, one's x. Right? So here's what we're going to do. I'm going to go ahead and I'm going to save this. We're going to pick up right here tomorrow. Okay? No assignment today. All right, and we'll pick up here tomorrow.